Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic is one MCQ, actually about the reaction of an ester. You can see this ester molecule. So what will be the product of this reaction, you have to say. And here 4 options are provided and one of them is the right answer. Believe me student, it's an easy question. So if you can try, then please, I suggest you please do it. Please pause the video, try by yourself, and whatever answer you get, please write in the comment box. And don't worry, after some time you'll get the right answer. I believe you have tried by yourself. It's my turn to give you the right answer. Now look at the problem a little carefully. So this is a very easy. This is actually a ester. In this ester, the acyl, this carbonyl group is attached to this tertiary butyl. Obviously this group is responsible to bulkiness, and second side it is ethyl. So conceptually I can say that this carbonyl is significantly enough bulky for nucleophilic attack. So nucleophilic attack on this carbonyl is not possible. Second thing, is there any alternate option? Yes, obviously there is an alkyl group. But if you look at this reagent, this is lithium iodide. So I can say lithium plus and I minus. Point number 1. Second thing, the reagent is DMF. DMF means N-dimethyl formamide. This is the dimethyl formamide or DMF structure. And we know this DMF has a canonical form. I mean that these will come here, it will open. So the structure is expected to be this is O minus H. This is carrying a positive charge. So from these you can expect that this DMF is significantly polar, and actually what is possible, this oxygen lone pair could be donated to lithium plus. So many DMF molecule can coordinate to this lithium and stabilize the cation. So just look at this, is a salt you have taken, lithium iodide. In that case the cation part is coordinated or stabilized. So obviously the anion will become free or uninterrupted because it is not that much strongly attracted by the cation, because cation is already got stabilized by the solvent, which means DMF. So anion became free and actually anion became more reactive. Secondly, we know that from fluorine, chlorine, bromine and iodine, in this halogen series, iodine minus, or more specifically we say iodide anion, is a very good nucleophile. So what can happen? Actually, if you look at that, this negative charge of iodide can attack here and it can come here, it can open. So actually this reaction is nothing but a SN2 type of reaction, or you can say nucleophilic attack followed by ester hydrolysis. So these 2 points is happening here. And obviously the leaving group, in this case this is this tertiary butyl carboxylic acid, this part is resonance stabilized. What do I mean by the statement? Just I have shown, but still I am showing it. This negative charge will come here, it will open. So I can say this is O minus, this is double bond. So these negative charge is delocalized, so it's stable, so it's a better leaving group. Point number 1. And the other part, this alkyl group of ester part, is converted into iodo derivative. Okay, so this is the reaction. So in this case what actually happens, the nucleophilic attack on one ester carbonyl is not possible due to bulkiness of tertiary butyl group. As I told, nucleophilic attack, I mean you may think that sir, iodide can, instead of this iodide can attack in this carbonyl group. No, not possible because of this bulkiness of this group. So that's why nucleophilic attack not possible, it attacking on this carbon. And ester is relatively better leaving group, means actually not ester, I more specifically say as carboxylate here. Carboxylate ion is a better, not ester, carboxylate ion is a better leaving group due to delocalization of electron density through this resonance. Okay, and third point is this ethyl group is less bulky for nucleophilic attack. We know that nucleophilic attack or SN2 type reaction happens more specifically or better way in primary substituted centers. So in this case, this ethyl carbon, it is a primary center, so SN2 reaction or nucleophilic attack is preferred. And interestingly, instead of ethyl ester, this tertiary butyl methyl ester, means in this case we have taken ethyl ester. Compared to that, if we take this ester, so OMe, just I am talking about this as the starting material, and you provide same reaction condition what is provided here, then the reaction rate enhances actually 10 times. So you can understand the reaction rate is dependent on the nucleophilic attack, because this methyl reduces the bulkiness, because we know the nucleophilic substitution SN2 reaction on methyl center happens the fastest, so it can attack very easily because it's least bulky. So that's why 10 time enhancement in reactivity is observed. So what is the answer here? Obviously this part. Now if this problem appear in your exam less than 30 seconds, how can you solve it? Now first of all, you need to understand two factors, that these ester is actually a bulky ester. Bulky means this alkyl group is bulky. So nucleophilic attack on this carbonyl group is difficult, point number one. And but there is another option, nucleophilic attack on these alkyl group. And iodide is a good nucleophile. Second thing, DMF is present as solvent which is capable to stabilize the lithium plus cation. So nucleophilic activity will be even further. So these nucleophilic attack will happen. This part we understand. So if it is happened, then obviously a carboxylate derivative possible. Now if I say carboxylate derivative, then only option B is left. Apart from that, if you think from another angle, see, iodide will attack this tertiary butyl group, not possible, because we know nucleophilic attack on tertiary butyl group not possible, is because of bulkness, option D gone. Now did I provide any reducing agent? Obviously not. So this ester could not be reduced into this aldehyde or carbonyl. No, this option gone. Second thing, there is a tertiary butyl group. At the beginning I told nucleophilic attack on carbonyl, carbon difficult. So this as new means acid iodide not possible. Only option B left. This is the answer. So in this way also you can come to the right answer. So in this case, student, I thanks everyone for watching this video. If you really enjoy the content of my channel, please help this channel to grow, and if possible, please visit my two other channel for learning.